Okay, so there are quite a few parameters that we can adjust on the LSPs. Let's have a look at some of the more common ones. So the first one would be bandwidth. Now we know that as we allocate bandwidth on an LSP, that bandwidth gets allocated on the egress interface. So if this is the flow of the data path going this direction here, then it's the egress interface that is allocated. What that means is if you had 100 apples and you allocated 50 and then you wanted to allocate 60, you wouldn't be able to do it. So on the one hand, the allocation isn't going to stop any data from flowing, but on the other hand, it's going to stop LSPs from being established if they need to be. Now, if you had a large network event, you may need to re-establish your LSPs. So on the one hand, it doesn't do anything. On the other hand, it has a huge impact. Okay, so we can have auto bandwidth. This is sort of a partly automated way to do this. Over an adjustment interval, there'll be various time slots, and at the end of the adjustment interval, the highest value of the time slot, bandwidth, will be considered the new requirement for the path, and it will try and reset the path bandwidth higher by sending out a path message. However, it's all a soft preempt, so it's not going to break before it makes. If the bandwidth isn't available, it'll try a path on another route. You can set your minimums and your maximum here. You can set your adjust interval. In this case, it's very long. It's been set to 48 hours. You can adjust that. You can also even adjust the adjustments and decide, well, let's say I've got it set for 5 hours. If I get 2 or 3 high readings, let's just jump for the high reading. There's a lot of adjustment there. Got priority next. 0 is the strongest and 7 is the weakest. This allows you to basically a new path to overtake an existing path. So by default, they're set to 7 and 0 for the setup and for the hold. And what that means is that with a setup of 7, it's designed that it can't just a new path can't throw off an old path. And obviously you want your hold to be less than or stronger or at least as strong as your setup. Otherwise you may get into an oscillation there between 2 competing paths. It's relatively straightforward. By default, it's set to 7 and 0. 7 is setup, which is quite weak, and 0 of hold, which is very strong. Okay, so what have we got here? We've got the soft preemption, does exactly what it says on the tin there. Then we've got the optimized timer. Now, obviously you may have a change in your network that doesn't get reflected into your LSPs. So you can change this timer. In this particular example, we've set it for 8 hours. You can have really quite short, and then what happens is it's going to reflect the ISIS network back into the LSPs and reset them up. But you can tune that. This is very important, adaptive. So by default, if we just imagine 2 paths that happen to be, one happens to be the backup to another, they're going through the same device. So this is the primary path. This is actually the backup path. Now, by default, the bandwidths are set to fixed filter, and what that means is that if you've allocated 50, say, apples on this path, and you allocate 50 apples on this path, it will consider that 100 apples. So the shame there is that in some cases the resiliency path can't be established because the primary path has taken the bandwidth. So by the keyword adaptive will change the style from fixed filter to shared explicit. And shared explicit means that if this is the backup path to this one, only count the 50 once. A good tune. Finally, we've got this little small scenario here. As we know, if we were to look inside the INET table, we would just be seeing the loopbacks and we'd be seeing the LSPs they're connected to. And obviously, BGP is the only protocol by default that's allowed to look inside the INET3 table and do resolutions. What we'd like to do, we've got a network here hanging off the IX, which is hanging off router 2. We have an LSP from router 5 to router 2. And we would like to install that prefix directly onto that LSP inside the INET3 table. And that's a command to do it. So basically, on the path, install and then that word. And install puts it into the INET3 table. And then if we put active on it, it also then copies that route into the INET0 for it to be used by other protocols. We can see it there. Run show route table INET3 and put the route in. We can see that we've installed that route into the INET3 table. Very useful command here. Run show route community name and then the community. And we can actually search the route table via community. And those are the first range of sort of tunings that we can do on the RSVP.